Okay, so now that we understand where the world frame is, the origin of the world frame, that is very important because we need to have an origin. So that is our world frame. That is the absolute position. Okay. Now we have to teach the robot the tool frame. So when you try to implement robotics in a factory, so know where the world frame is and then teach the robot the tool frame. Okay, so the default tool frame origin is on the center of the faceplate of the robot. Okay? But the robot is useless if it is just like this. You need to add either a gripper, okay, or a welding torch, or for painting, sprayer. So you add those different tools, and now it moves the origin of the tool frame. So that's the default tool frame. And then if you add another tool, then that's the new tool frame, and we have to teach the robot that one. Okay? So to easily understand it, like for example, a person playing volleyball. So where is the end of tool of the person? The hands, right? But then if he plays tennis, he adds that racket which extends his end of tool. And he doesn't use his hand as his end of tool. If he does, then he will not be like Roger Federer. Okay? He will be like Tiger Woods. So you have to extend, and you have to teach the robot that one. So that's the tool center point. So how do we teach the tool frame? So this is an example. That's the center, the tool frame origin. For example, you will be adding this tooling. And once you have positioned the tooling, then you need to add the frame offset. So now we can teach. Okay, so here are examples of tool center points, the adjusted offsets. So this is for a sprayer, a welding torch, spot welder, and a gripper. Okay. So I remember when I worked with apple harvesting robots. So our end of arm tooling is in the center of the gripper when we get ready to pick up the fruit. So there are three methods of defining a tool frame. You have the 3-point method, the 6-point method, and the direct entry method. So let's start with direct entry method. The direct entry method is used when the tool dimensions are known. So you just enter those values X, Y, Z, and the direct entry must be used with 4-axis robots. Okay, and then we have this 3-point method and the 6-point method. So with these two methods, we don't need to know the exact position of the tool dimensions. Okay, so 3-point method defines just the location of the tool frame. Okay, the 6-point method defines both the location and orientation. So if you want to use the tool frame in jogging, the robot, and you are basing your jog movement on the tool frame, then you have to use the 6-point method. But if you are only concerned with the tip position of the new tool frame origin, then you can just use the 3-point method. Does that make sense? So here is an example of teaching a tool center point using 6-point method. Step 1, approach that point at a certain direction. Okay? And in step 2, approach the same point in a different direction. And then record that position. That is approach point 2. And then step 3, you approach it again in another direction, the same point. So we need 3 different approach points, record those points, and then it will teach us the position of. So that is the first part of the 3-point method. Adding this 3 position, origin position, that's the 4th step, and then record the X direction based on that origin position, that is the 5th step, and then record the Z direction based on that origin, and that will give you the 6th step. That's why it's called the 6-point method. The first half completes the 3-point method. The second half adds the orientation of the tool frame. Okay? So we will now try to test and teach the tool frame of the robot.